Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to learn all about the quadratic formula. So last time we looked at three ways of solving quadratic equations: guessing, just putting in numbers seeing if they work, drawing the graph, and factorization. Today we're going to look at the quadratic formula. Next time, completion of the square. So here is the quadratic formula: x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, towards the end of the session, we'll just learn how this was derived. In other words, how we start with ax squared plus bx plus c equals 0. So we start with that, which is just a general quadratic equation. And then we get to x equals minus b plus or minus square root b squared minus 4ac over 2a. In a sense, we're solving for x. That's Chewy having a shake. So we will we'll show how to derive it, but also it is just worth memorizing this. I mean, it's a bit like memorizing the word crocodile. It's just worth learning. And what's interesting is when I wrote this, I didn't even check on Wikipedia what the formula was, because I just know it. It's like you don't have to check the word crocodile, you just know it. And that's very useful in maths. It's not just a quadratic formula, it's quite a useful thing to do generally. Anyway, so here's the formula. So basically, a is the number of x squareds, b is the number of x's, and c is the constant. And when that's the case, you can find x with this formula. So let's just look at an example, and we're going to look at Gary's closing question from the last session. So if x squared minus 4x plus 3 equals 0, what is x? So we go back to our formula and we say, well, b is minus 4, a is 1, c is 3. So we pop them in. We get minus b, which is minus 4, plus or minus the square root of b squared, so minus 4 squared, minus 4ac. 4, a is 1, c is 3. All over 2a, a is 1. So minus 4 is just plus 4. And then minus 4 squared is minus 4 times minus 4, which is just plus 16. Plus 16 minus 12, so we've got square root of 4 there. So we've got 4 plus or minus the square root of 4 over 2. 4 plus or minus square root of 4 over 2. 4 plus or minus 2 over 2. So basically, when it's minus, you get 4 minus 2, which is 2, over 2, which is 1. And when it's plus, you get 4 plus 2, which is 6, over 2, which is 3. So this plus or minus thing gives us two answers. So often, quadratics have two answers. Sometimes they have one, and sometimes they have none. But to get the two answers, we need this plus or minus mechanism that you see before the square root. It's nothing too complicated. It just means that you can either add or take away, and in both cases, it gives you an x. Okay. So in this case, we get 1 or 3. Since this came from the last session, and the last session was on factorization, I'll just show you the factorization. So basically, x squared minus 4x plus 3 factorizes as x minus 3 times x minus 1. And so, of course, when that equals 0, either x minus 3 equals 0, in which case x is 3, or x minus 1 equals 0, in which case x is 1. This is the curve. So here we are, y equals x minus 4 plus 3, and we can just see, y equals x squared minus 4x plus 3. I'm just rushing because it's so exciting, and also because I've got to drive someone to the station soon, to the bus station. Okay, so no more rushing. Y equals x squared minus 4x plus 3. This is the curve. And we can see it touches the axis at 1 and 3. Okay, let's look at one more. X squared plus 6x plus 9 equals 0. So we pop them in. So we've got, this is the formula. So b is 6. C is 9, A is 1. We've got minus 6 plus or minus square root of 6 squared minus 4 times 9. So 6 squared is 36, 4 times 9 is 36, so it's 36 minus 36. So this is going to become 0 here. We're just going to get minus 6 over 2. Minus 6 over 2, plus or minus 0, it doesn't matter because it's only 0, which is minus 3. So in this case, the curve looks like this. Y equals x squared plus 6x plus 9. It just touches at minus 3. It's really pretty. Okay. Here's another. Minus x squared plus 3x plus 10. So in this case, a is minus 1. It's not 1. B is 3. C is 10. So we pop these in. Okay. Minus 3 plus or minus the square root of 3 squared, b squared, minus 4ac. So minus 4 times minus 1 times 10. So that's plus 40, because there's two minus signs, and a minus times a minus is a plus. So it's 9 plus 40, minus 3 plus or minus square root of 49 over minus 2. So its square root of 49 is 7. So when we add that, we get 4 over minus 2, which is minus 2. And when we subtract the 7, we get minus 10 over minus 2, otherwise known as 5. So the answers are 5 or minus 2. Here's the picture. Also, because we've got a negative coefficient on the x squared, because a is negative, the curve is actually the other way up. So instead of being able to catch rainwater, it looks like a little hill. Okay, one more. X squared plus 4x plus 5 equals 0. So we've got b is 4, we've got a is 1, we've got c is 5. Here's the formula. So when we pop things in, here's what we get. Minus 4, that's fine, plus or minus the square root of 4 squared, which is 16. Minus 4 times 5, which is 20. So actually what we've got here is the square root of a minus number. Now we can't find the square root of a minus number because 2 times 2 is 4, and minus 2 times minus 2 is 4. So there's no number that could be the square root of minus 4, because basically when you times two numbers together, if they're both positive, it comes out positive, and if they're both negative, it comes out positive. So we can't find square roots of minus numbers, and so consequently there's no solution. And this is very useful because this tells us that the quadratic has no solution. Pure factorization wouldn't do that. You'd just be trying loads of numbers and not getting ones that worked, but you never really know that there wasn't an answer. And also guessing wouldn't let you know either. Now drawing the graph does let you know, and here's the graph. And the point is, this graph does not quite touch the axis. Actually, the closest it gets is 1 unit off the axis. So the fact that it doesn't touch the axis shows that there's no solution to x squared plus 4x plus 5 equals 0. Okay, so that's just some goes at applying the quadratic formula. Now here's how we derive it. So ax squared plus bx plus c equals 0. We start with this. Now the first thing we're going to do is divide through by a, divide everything by a. Now we can do this because we know that a is not 0. If a was 0, this would just be a simple linear equation with no x squareds, and we'd solve it in a different way, as we showed in a previous algebra video. So a is not 0, we divide by a, we get x squared plus bx over a plus c over a equals 0 over a, which is just 0. Next, we're going to add in, now this looks a bit weird, but all will become clear further down the line. We add in b squared over 4a squared, then we take off b squared over 4a squared. So that's absolutely fine. That doesn't change anything. We've just added in a thing and taken off the thing. And that equals 0. Next, these three terms on the left, they are actually an exact square. So it's worth checking this if you want to in your own time, but these three terms on the left equal x plus b over 2a all squared. The reason is because if you multiply this out, you get x times x, which is x squared. Then you get bx over 2a, then another bx over 2a, and then those two add up to make 2bx over 2a, which then cancels down to bx over a. And then finally you've got b over 2a squared, which is b squared over 4a squared. Let's go to it. B squared over 4a squared. So this was constructed on purpose. These three terms become an exact square, looking like this. Okay, then next stop, we're going to take c over a from both sides, and we're going to add b squared over 4a squared to both sides. So what you get is b squared over 4a squared here, minus c over a, and then the terms on the left just disappear. Then we're going to create a common denominator. So we're going to create a common denominator for these two. So when we're subtracting fractions, and we showed this in our fractions video, when we're subtracting fractions we need to create a common denominator, and there's nothing different in algebra. So we're going to put all of this over 4a squared. So we're going to times the top and bottom of this by 4a. So So we get b squared over 4a squared minus 4ac over 4a squared, which is just b squared minus 4ac over 4a squared. Next, and maybe you can see now we're starting to get there, we're getting close to the answer. We square root both sides, so x plus b over 2a equals square root b squared minus 4ac all over 2a. We subtract b over 2a from both sides, which gives us minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. That is the correct quadratic formula. We got there. So you can still use the quadratic formula without knowing the derivation, but knowing the derivation is just a really nice thing. It just gives you more confidence and it helps you know where it's come from. Actually, the process we just went through was a completion of the square, and the next video we do will be completion of the square, so those things are kind of connected. So here's Gary's closing question. X squared plus 4x plus 4 equals 0. What is x? Answers in the comments, answers on a postcard, or just do it yourself if you would rather do that. It's completely up to you. Really hope you've enjoyed this. Please hit like if you have, and if you'd like to see more in the future, please hit subscribe and the notification bell. We're going to do completion of the square, then after that maybe number bases, and I think after that decimals and percentages. But, you know, there's still a lot of calculus to come, so there's lots of things to come. I hope you're enjoying yourself, whether you're in lockdown or you've come out of lockdown. I hope it's all going well, and I very much look forward to seeing you next time. Chewy says goodbye. There he is, just kind of cuddled up on the bed. He's going to come with me to the bus station, aren't you, Chewy? All right, keep well, everybody. Bye-bye.